The extensive use of computers has been accompanied by a large and growing vocabulary of computer-related terms and conventions. Familiar terms such as word, address, and location have taken on different or special meanings whenever they're used in connection with computers. The more elementary computer terms and conventions will be defined in this study unit, which is divided into 3 lessons. Lesson 1 introduces and defines the basic units of information that are used in digital computers. Lesson 2 defines terms pertaining to the storage and retrieval of information. And Lesson 3 describes the basic units of time that are used whenever we talk about the operating speed of computers. Now let's begin Lesson 1. Digital computers are constructed of electronic circuits having only 2 operating states, on and off. By convention, when a circuit is electrically switched to the on state, it represents the digit 1. Conversely, if the circuit is switched to the off state, it represents the digit 0. Therefore, a digital computer can only work with the digits 1 and 0. The computer cannot work directly with decimal numbers, letters of the alphabet, or special symbols. All information, instructions as well as data, must be converted into specific combinations of zeros and ones that can be accepted by the computer. Numbers which can only have a value of 0 or 1 are sometimes called binary digits. Another more frequently used term is bit. The term bit is simply an abbreviation of binary digit. It's obtained by taking the first 2 letters in binary and combining them with the last letter in digit. Because a bit can have only a value of 0 or 1, it represents the most basic unit of information used in digital computers. Individual bits are awkward to work with. Therefore, they're usually combined into a larger unit of information called a word. The number of bits contained in one computer word depends on the design and the size of the digital computer. For example, in a minicomputer, a word may contain as few as 8 bits. On the other hand, in a large-scale computer, there may be 36 or even 60 bits per word. Today, the most common word sizes for minicomputers are 12, 16, and 18 bits. Each computer word may contain either data or an instruction. If the word contains data to be processed, it's called a data word. If the word contains an instruction, it's called an instruction word. The computer is designed so that it can store individual words in its memory or retrieve words from memory. However, the computer cannot store or retrieve individual bits of information. In summary, a word consists of a fixed number of bits that are handled and processed as a single unit of information. In some digital computers, words can be divided into smaller units of information that are called bytes. Bytes are also handled and processed as single units of information. A byte is usually 1/2 or 1/4 the size of a computer word. For example, if a minicomputer uses a 12-bit word, then each byte contains 6 bits. On the other hand, if the minicomputer uses a 16-bit word, then each byte contains 8 bits. In this lesson, we've defined 3 basic units of information: bits, words, and bytes. The bit is the smallest and the most basic unit of information. It's either a 0 or a 1. Individual bits are usually awkward to work with, so they're grouped together to form a larger unit of information called a word. In a computer, the number of bits contained in one word is fixed at the time the computer is designed. The most common word sizes for minicomputers are 12, 16, and 18 bits. Some computers are designed to handle and process a smaller unit of information called a byte. A typical byte is generally 1/2 or 1/4 the size of a computer word. This completes our first lesson on computer terms and conventions. Now go to your workbook for review material and practice exercises. The workbook will tell you when to return to this program. In this lesson, we'll define some basic terms pertaining to the storage and retrieval of information. Information is stored in main memory until the central processor, or CPU, is ready to retrieve and process it. The stored information consists of instructions along with the data to be processed. The instructions and the accompanying data are stored in individual cells called memory locations. These memory locations are used in much the same way as a series of post office boxes. Just as a post office box stores mail, so too each memory location stores information to be used by the CPU. However, there is one important difference. A post office box may hold many pieces of mail. On the other hand, a memory location can hold only one instruction word or one data word. A different number, or address, is assigned to each of the post office boxes. The box address specifies where a letter is to be placed or stored when it's received at the post office. Also, the box address is used again for locating mail that is to be picked up or retrieved from a specific post office box. Main memory is addressed in much the same way as our post office boxes. Each location in main memory also has an address assigned to it. This address identifies the memory location, but not the information that is contained in the location. In other words, the memory addresses are fixed at the time the computer system is designed and manufactured. These addresses are permanent. They cannot be changed. However, the contents of the memory locations can be changed. To store data in main memory, the central processor specifies the address of the memory location that is to receive the data. This action is referred to as addressing memory. When the new data is stored in the memory location, it replaces the previous contents of the location. To retrieve data stored in memory, the central processor again specifies the address of the memory location from which the data is to be retrieved. However, when the data is retrieved from the addressed memory location, the contents of that location, the data, are not destroyed. A copy of the retrieved data is retained in the memory location so that the same data can be used over and over again. Thus, main memory consists of thousands of storage locations. Each location is identified by its own unique address, so that the CPU can go directly to any memory location and either store a word or retrieve a previously stored word. Memories come in different sizes. Whenever we talk about memory size, we're referring to the total number of words that can be stored in the memory. The letter K is frequently used to describe memory sizes. When used to describe the size of computer memory, K represents the value of 2 raised to the 10th power, which is equal to 1024. Note that this convention is different from other fields where the term K is taken from the metric system to represent the value 1000. For example, outside of the computer industry, the expression 4K denotes 4 times 1000, or 4000. However, in the computer industry, a 4K memory denotes 4 times 1024, or a total of 4096 words of memory. If the memory size is increased to 32K, then main memory can accommodate 32,768 words. And if the memory size is increased further to 128K, then main memory can hold over 131,000 words of information. Remember, each memory location is given a unique address. Consequently, if there are 128K locations, there must also be 128K addresses. At this point in the lesson, refer to the review material and the practice exercises contained in your workbook. The workbook will tell you when to proceed to the next lesson in this study unit. In this lesson, we'll discuss basic units of time that are used to specify the operating speed of computers. A digital computer operates at very high speeds, performing 500,000 or more additions every second. Because of its high speed, each computer operation must be measured in a very small fraction of a second. The most common units of time are milliseconds, microseconds, and nanoseconds. A millisecond represents 1/1000th of a second. In other words, if 1 second is divided into 1,000 equal parts, then each part equals an interval of 1 millisecond. Many of the operations that take place in input units and output units are specified in milliseconds. However, a millisecond is still too long a time interval for operations that involve the CPU or main memory. Therefore, smaller time intervals, microseconds and nanoseconds, are more convenient for us to use. A microsecond represents 1/1,000,000th of a second. Thus, if 1 second is divided into 1,000,000 equal parts, then 1 part represents 1 microsecond. A nanosecond is even smaller. It represents 1/1,000,000th of a second. It's more convenient for us to use microseconds and nanoseconds whenever we talk about the operating speed of the computer mainframe. For example, in just 2.5 microseconds, this minicomputer can perform 1 addition. And in 800 nanoseconds, the central processor can locate and retrieve a word stored anywhere in main memory. Let's review the 3 basic units of time that we've defined in this lesson. A millisecond represents 1/1000th of a second. It's usually abbreviated MS or MSEC. A microsecond denotes 1/1,000,000th of a second and is abbreviated µS. The smallest unit, a nanosecond, represents 1/1,000,000th of a second. The abbreviation for nanosecond is NS. A summary and examples of these 3 units of time are included in your workbook. The workbook also contains a list and an explanation of the standard symbols that will be used in this course. You should now refer to the material and practice exercises provided in your workbook.